There it works. All right, so yesterday we left off starting to figure out how to count significant figures. Just a quick review. Non-zero numbers count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. We count those as significant figures. In example number 3 there, a sandwich zero counts. In example number 4, if it doesn't have a decimal place, then we don't know if we count it and it ends the number, right? Because that 525,010, that zero at the end right here, this, we don't know. So we call it ambiguous, 5 or 6. Then we did another example, 5. And then what we decided to do is, well, what if we wanted to show 6? Then we would do scientific notation. And let's just do another practice. What if I had a number 15.00? 15.00. So are we good with 1 and 5? Those count because of rule number 0. And Wyatt, by the way, you are looking on page 30 of this packet, and there are rules for how to count. So rule number 0, you guys, is the first bullet point, and I called it 0 because it didn't have a number. Non-zero integers are always significant. So that means they count. And what rule tells us whether those zeros count or not for significant figures? Rule number 1, 2, 3. Rule 2, if a number has a decimal point, okay, first of all, it does. Any zeros at the right end of the number are significant. Yes. Oh, you should start right here, below that. So because there's a decimal point here, this 0 is significant. It ends the number. And then this one is sandwiched. Because this one is significant and this one is significant, this 0 right here is a sandwich. So we'll count it. All right, so rule number 0 helps us. Rule number 2 told us that trailing zeros to the right of the decimal, it counts. Then zeros between, well, it's like zeros between two non-zero numbers. It's kind of rule number 1. But we could also just say it's any 0 that's between two significant digits counts, a sandwich number. So this, in fact, has 4. All right. What if we have a number 0.003070? What if we have that? We good with the 3 and the 7? Yeah? Because they're non-zero numbers? Okay, so that's rule number 0. It tells us that all non-zero integers count. This one in between the 3 and the 0, we're all good. It's a sandwich. So that's number 1. If you read rule number 2, it does in fact have a decimal place, Amir. And so this 0 right here counts because it's to the right of the decimal place. How about these? What rule tells us whether those count or not? Which one? Yep. Rule 4. Guadalupe says rule 4, leading zeros. So this is a little bit confusing because we've got a decimal place and we have zeros to the right of it, but they're not ending the number. They're leading the number. So yes, there's a decimal place. This 0 is ending the number, so we count it. But because these are all leading, we do not count it. So this, in fact, is only for sig figs. Now, if I took that same exact number, but there was, let's say, a 1 in front of it, so it was 10 0.003070, lots of zeros. We already knew that these were all significant, but now the three leading zeros, they're not leading anymore because this one counts. It's a non-zero integer. Therefore, these are now considered sandwiched zeros. So we'll have 1, 2, 3, 4, 5, 6, 7, 8 significant figures in this particular number. You're going to have a lot of practice with this, and then this will be a skill that I'm going to ask you for the rest of the school year. All calculations, all reported numbers always have to be in proper sig figs. In fact, it's really frustrating when you know how to do a very difficult chemistry problem and then you get it wrong because of significant figures. That's a bummer. I mean, I'll feed it back to you so that doesn't happen, and I'll probe you like, hey, right number is sig figs? And I'm like, oh, I hate sig figs. Okay, yeah, let me go fix that. Okay, so don't worry if you don't exactly know what you're doing right now. You'll have plenty of practice. Cody. You can. Okay. Will you be back?
I don't know.
Okay. Remember, if you're not back, I'll try and get this online by tomorrow, and then look at your homework. All right. So what I'd like to do right now is tell you about reporting. So if you are measuring, now measuring could be with a ruler, measuring could be with a scale, it could be with a graduated cylinder, it could be with a beaker, it could be with a thermometer, right? So you can measure a lot of things. If you are measuring, you must report your answer or your measurement to one more, how do I say this? One more decimal place than as accurate as the measuring device. I'll write that down. To one more decimal place, and that's to the right. One more decimal place than the measuring device. Lots of words here. Measuring device. So, first of all, let's just talk about this. I have it up on the board right here, but go ahead and write it in your notes. This is the measuring to the 1,000s place, right? So if you had a device that measured every 1,000 meters, let's say, this one is 100. Maybe a very large beaker measures every 100 milliliters. This measures the tens place. This is what we call the ones place. This is 1/10, so we call it the tenths place, but honestly the TH at the end is a little cumbersome to say, so I usually say the first decimal place, second decimal place, third decimal place. But in fact, this is 1/100th, and this is 1/1000th, and we could keep going, but we won't for now. So if your measuring device, let's say you had a ruler and it measured to this place right here, you would report your answer with 2 decimals. So if you measured it and it looked like it was on the ruler at about 9.2, because you know you've got 9 and you have 10 and 5, 1, 2, 3, 4, 6, 7, 8, 9. Right, so you have a ruler like that, and, oops, hold on. So if you have a ruler and it measured at 9.2, like right there, whatever it is, it looked like it was about there. You don't report it as 9.2. You report it as, well, I feel that's like maybe a 9.22. You always go one more accurate than the device. Okay? You'll have some practice, don't worry. The next and last thing I'd like to talk to you guys about is rounding. So the rules for rounding, you look at the number. You look at the number to the right of where you're rounding. So you look at the number to the right of where you're rounding. If that number is greater than or equal to 5, I put X for that number, okay? Then you round up. So, for example, if you had 1.56 and you needed to round this to two significant figures, or you were trying to round to that place, you would look at this 6. Oh, geez, that's not what I wanted to do. You would look at this 6 right here, and because it's greater than 5, you would say, okay, I need to round up. So it's 1.6. What if you had 1.56 and I needed it to be one significant figure? I would have to round here, and I would look at this number. And so now, because that's equal to 5, I would round up. So depending on how many significant figures you need to show, sometimes you have to round your numbers. Yeah, Bryce. Oh, so if you're saying 1.46 and I needed to round to here, yeah. So you look at this number. So I guess I need to tell you the next rule to answer Bryce's question. If X is less than 5, then leave the number the same. So Bryce's question here, if I was rounding right here, this 1, I look at the 4, what this is just 1. I leave the 1 alone. Or if I had something like 1.32 and I needed to round to this decimal place, I look at the 2, that's definitely less than 5, so that just equals 1.3. So depending on where you're rounding, I liked your question. Do you go 2 places over? Nope, you can ignore all, because, I mean, literally, what if you had a number that was like this? And I said round it to 2 decimal, or to 2 sig figs. That means right here, you look at this 7 and you ignore all that. Who cares? You just look at the 7, and it is above 5, so it would be a 1.7. And this would be 2 sig figs. Okay, and we're finally done with this lecture. Yay, now let's do some practice.